Okay, so today we have 4.6 notes and explain how you can prove that angle A is congruent to angle C. So what we have been doing in chapter 4 is proving that one triangle is congruent to another triangle and then stating the congruence postulate or theorem, and we're done. But now we have one more step. So there's another added concept today. It's just one more step. Like if you were doing a proof, it would just be one more line that you would have to do on the proof. And that is to say, okay, this triangle is congruent to that triangle. Therefore, these corresponding pairs of parts are congruent. In other words, this angle is congruent to that other corresponding angle of the other triangle. Or this line segment is congruent to the corresponding line segment of the other triangle. So it's just adding one more step to what we already know. In summary, if we say that one triangle is congruent to another triangle, which we've been doing all chapter, then now we get to say, okay, then this corresponding part is going to be congruent to the corresponding part of the other triangle. So in this one we have BD is congruent with BD because of the reflexive property. We also have AB is congruent to BC, and AD is congruent to CD, and that's given. So we can now state that triangle ABD is congruent to triangle CBD because of side, 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 right? We have these, oops, didn't mean to do that. We have these two sides are congruent, given. These two sides are congruent, given. And this is obviously congruent with itself, reflexive property. So we have side, side, side. So if the two triangles are congruent, then all their corresponding parts are congruent. So this is kind of basically the new material today. This stuff is kind of the new concept that we're doing today. Okay? And therefore we could say that angle A then is congruent to angle C. We didn't know that before. It wasn't stated directly in SSS. But now we can say, okay, then angle C is congruent to angle A, or angle A is congruent to angle C, right? You could say that either way, commutative property. So we have those two angles are equal, and the reason you could say that is because of CP, CTC. Corresponding parts of congruent triangles are congruent. So just realize that the abbreviation CP-CTC stands for corresponding parts of congruent triangles are congruent. And then from now on, all you need to do is write that in a proof, CP-CTC. Let's say you want to find the distance across a river, but you cannot cross the river. You must stay on your side of the river. How would you find the distance across the river? So here's my little picture here of the river, what's going on here. Basically, we're on this side of the river, and we have some people over here on that side of the river, and we can't cross over there for some reason, but we want to get the peaches off the peach tree. So this is the peach tree. I tried to make it an orange tree, but I couldn't get the right shade of orange. So we're going to call it a peach tree. So we're trying to find out what the distance is between N and P without having to cross the river. Now, if you were in class today, we engaged in discussion as to how we would do that, how we would tackle it. We kind of had a plan going on, talking about similar triangles, but I really can't mimic that method here by myself, so I'll just move right along. We're trying to find the distance between N and P so that we can build a bridge. Well, we need to know how long that bridge has to be. So the first thing you would need to do is to walk down on your side of the river, right? You have all the angle measuring devices and all the tools and like a yardstick or a tape measure. You can measure, you can do a lot on your side of the river. You just can't cross over to the other side of the river. And you don't have a boat or anything like that. So you would just walk along down and put like a wooden stake at point K. So you have a wooden stake at point N, a wooden stake at point P, and then a wooden stake at point K such that NK is perpendicular to NP. You would just construct it that way. And then you would put a stake down at point M such that it is the midpoint. That's important to remember, people, that M is the midpoint of NK. So you can do that, right? You can measure the distance of NK because we're on this side, and we can just start at point N and just go down and measure to point K and find out what that distance is, right? Oh, and I just realized that earlier I said put a stake at point P. Well, obviously you cannot put a stake here at point P because we can't cross that side of the river, but anyway, you can put a stake at N, M, and K. Remember, M is the midpoint of NK. Then, excuse me, you'd put another point here, another stake rather, here at point L, such that LK is perpendicular. LKN is a right angle, and points M, P, and L are collinear. You could do that, right? You would just line up your eyes, and you would say, okay, point P aligns with point M. I'm at point L, so you have that straight line between L, M, and P, and you have that point K, and it is a right angle. So now how does this help you find the distance of NP? And again, when we were in class, we had a lively discussion on this, but I'll just have to move right along. So get this concept down. How does this help you find the distance of NP? Well, we have, if we can prove that they're congruent triangles, then by CP/CTC, we can prove that LK, that LK is the same distance as NP, and then all we have to do is measure the distance of LK, and that would be the distance of our bridge. So we have this figure without the river or any of the other extraneous information there. And so we think of these as two separate triangles, MLK and MPN. And we have that angle N is congruent to angle K, right? Because they're both right angles, so they're congruent to each other. We have line segment NM is congruent to line segment KM. And in class I asked why that's so. And the correct answer is, well, because I said M is the midpoint. We made it that way, right, when we were on that side of the river. And we also have angle KML is congruent with angle NMP. In other words, what I'm saying is this angle must be congruent with that angle, and that's true because of vertical angles. So we have everything we need to say that triangle MLK is a congruent triangle with MPN. They're basically the same triangle, and that's because of ASA, angle side angle, where the side is literally in between the two angles. And so now we have all corresponding parts of these two triangles are congruent. In particular, we're concerned with KL being congruent with NP. And how can we say that line segment KL is congruent to line segment NP? Because of CP/CTC. Corresponding parts of congruent triangles are congruent. So the answer to the riddle would be you measure KL, and that's how long the bridge must be. And that's it. If you have any questions, please feel free to come see me anytime. Bye-bye.